Welcome everyone, and thank you so much for joining this session today. We are having our session today. Please, let's mute ourselves. Okay, thank you so much, and welcome to our today's session. I hope you can hear me.
Jimmy, can you mute Adam Ibrahim?
Hello, is it?
You mute Adam Ibrahim.
Okay, thank you so much, everyone, and welcome to our today's session. This is a webinar organized by Students Against Superbugs Africa in collaboration with the American Society of Microbiology. And my name is Jimmy Gaiwate, the head of research at Students Against Superbugs Africa. We are so happy to have you today, and we do hope that we are going to learn together. Thank you so much. So, Students Against Superbugs Africa is a youth-led organization that champions against the threats of antimicrobial resistance across the African continent. And we do mainly involve the young people, that is mostly the tertiary level students across the continent. And we have been in collaboration with the American Society for Microbiology, which is also an organization or a platform comprising of members, including researchers, educators, and health professionals, especially from the field of microbiology, though involve other scientists and professionals from other fields. It's the largest professional organization dedicated to the life sciences, and it promotes advances in microbiology sciences by publishing highly cited publications, running multidisciplinary meetings, deploying their resources and expertise around the world, advocating for scientific research, fostering a deeper public understanding of microbiology. So that's one of the principles we work in the fight against antimicrobial resistance, as well as the promotion of microbiology research and education. They are also involved in advanced microbiological sciences, support microbiology professionals, improve the global health, as well as connecting science and their mentors and the public. So today in our session, we have Professor Joel Bazira, who is and Dr. Lisa Ngada. And I'm going to introduce our speakers right away so that we can go on with our session. And our first speaker is Professor Joel Bazira, who is a medical doctor, an associate professor and head of Department of Microbiology in the Faculty of Medicine at Mbarara University of Science and Technology. He is a holder of MBCHB at Mbarara University of Science and Technology in Uganda, and a Master of Medicine in Microbiology / Immunology, University of Dar es Salaam, and a PhD from the Mbarara University of Science and Technology, Uganda. Joel is a Fulbright Scholar, a Fellow of the Uganda National Academy of Sciences, and Fleming Fund Fellow. He is a member of the American Society for Microbiology, Uganda, the Medical Association, and React Africa Network. He is also a member of the Technical Working Group, One Health Platform, the Ministry of Health, Uganda. Today we have our great speaker here, and without taking much time, let me invite Professor Joel to take up over the session. Professor, if you can hear me, take over from the session. Thank you so much.
Okay, thank you very much, Jimmy. I hope I'm allowed to share my screen. Oh, someone needs to give me permission to share the screen.
Yes, let me enable you. I think you should be able to share a screen.
Not yet.
Yeah, now it's okay. You can go on. Prof, you should be able to share a screen now. Yeah, I think, yeah, you're now the co-host. Go on, Prof.
Okay. Yeah, welcome members to this wonderful time that we are having to share and a few thoughts about drug resistance. As we know, it's really a big challenge, and I'm glad that we have student chapters that have also come on board to address One Health or to address antimicrobial resistance. I'll share briefly about development of antimicrobial resistance, and hopefully you will learn a thing or two. From here, you can see that we have antimicrobial drugs, and these are agents that actually interfere with growth of microbes. And when we talk about antimicrobial resistance, many people actually imagine that we are talking about antibiotics or antibiotic resistance. But antimicrobial resistance is a bigger kind of spectrum that includes the antibacterials or the antibiotics. And of course, these are the commonest agents that we use, probably on the ones we use mostly are less toxic. And as you can see, they work on unique bacterial pathways. We also have antivirals, antifungals, antiparasitic agents, and antihelminths. And these ones vary in their degrees of toxicity. The most safest probably of all these antimicrobials would be the bacterial agents. And since 1928, when penicillin was developed, up to probably 10 years ago, we have had 14 new classes of antibiotics. Sometimes when we share this, people say, no, but we have amoxicillin, we have penicillin. We are not talking about the modifications of these molecules. We are talking about the actual molecules, the actual antibiotics. We're talking about a penicillin. We're talking about a cephalosporin. So there are about 14 classes of antibiotics. And as we know that antimicrobial resistance simply means the ability of these microbes to persist or to grow in the presence of drugs designed to inhibit or to kill them. And as early as when Fleming Alexander discovered the penicillins in around 1927, he predicted that in a short while, resistance was going to develop. So it was just that. And this is because resistance is a natural phenomenon. And this, I put this in red so that you really understand. Resistance is not artificial, resistance is natural. It's there in these organisms. And so it's only amplified when these bugs or microbes are exposed to antimicrobials. And this is very important for us all here to understand, and probably for all human beings who use drugs to understand that natural resistance is a natural phenomenon. These bugs really have these genes in their inside, but these genes are switched on in the presence of drug pressure. These antimicrobial resistance genes have been found in organisms as far as Antarctica, where they have never used antibiotics. So these are natural things, a natural phenomenon, but we as human beings who use drugs, we amplify this phenomenon. And of course, because we are using drugs everywhere, you find drugs in drinks that we use, we find drugs in food, we find drugs as growth promoters for animals, for plants, for conditions which are not necessarily supposed to be indicated for them. We use them a lot. And because of that, these organisms are also increasing the pace at which they are resisting the drugs. And that's a very, very important message. That's why I highlighted it for us in red. So these are basically showing you that these drugs were approved in the 40s, but I think this is not true. It is the other way around. The drug was reported was in 1940. Even before its approval, you find that resistance had already been seen. The penicillin, streptomycin, these tetracyclines. The time between the approval and the time of resistance is really quite short, which means we push a lot of these drugs as long as they're approved. We use them a lot, and then we develop resistance. So this is the message that we want you to take with you, that drug use or drug pressure is very key in the development of drug resistance. We just amplify this resistance that has been in there. And as we know this problem, I think we are singing to the converted. AMR actually poses very significant burdens in healthcare. The biggest challenge with AMR that we have faced in the AMR world is that it's difficult to point to a mortality, to a case fatality and say this is due to AMR, as it is opposed to saying this person died of malaria, this person died of HIV, this person died of typhoid. You know, we cannot point directly, and that becomes difficult to really convince many people that this is a problem. It's until you are suffering with it yourself, like you go to hospital and they give you good medicine that is safe and cheap and it doesn't work, and you have to take another dose of a more expensive medicine that's actually less effective with more side effects, that you realize that, wow, we're in big trouble. Think about somebody with TB, and ordinary TB is curable. 6 to 9 months, you get onto your feet and run. But then think about somebody who gets MDR TB and has to take injections for 2 months. You know, it's that tough and it's that bad. So it's a significant problem in healthcare. And as WHO estimates, we have about 4.9 million fatalities, about 5 million people die due to these infections. And as predicted by George O'Neill in the O'Neill report of the United Kingdom that actually led to the institution of the Fleming Fund in UK that supports many countries, including Uganda, about 10 million people will lose their lives by 2050 if nothing is done. And most of these deaths are actually in Africa or in low middle-income countries, in places where we still have infections. In some countries, they have moved away from really infections. It's only in middle-income or low middle-income countries where we have lots of infections. And these statistics come through the US, but even here, we do have lots of infections that are happening in our ICUs. We have a colleague here who is going to do a study in our ICU at Mbarara to really look at these drug-resistant infections. But from some of the work we have seen, the statistics are not very nice, very, very alarming statistics coming through from our end. And MDR is acquired, is an acquired non-susceptibility to at least one agent. This basically trying to define what MDR is, and people can define it in many different ways, but it's basically you have resistance to at least 3 antimicrobial categories. You know, it's not just resisting penicillin, ampicillin, and amoxicillin, but you're resisting a penicillin, you're resisting a macrolide, and you're resisting an erythromycin. So 3 different categories. That's when you become an MDR. And this basically comes from a combination of different independent mechanisms of resistance. I'm sure you already know what mechanisms of resistance that bacteria use. So when you combine this, then you have one organism that is actually resisting many classes of drugs. And this enables a disease-causing organism to resist distinct drugs of a wide variety of structure and function targeted to eradicate the organism. So these organisms become literally difficult for us to treat because they go and resist not just one class of drugs, but different classes of drugs. And cross-resistance occurs in antibiotics, usually of the same family. So if an organism is resistant to penicillin, it will probably be resistant to cephalosporins because they all carry the beta-lactam ring. So what are some of those factors that we think help in the emergence of resistance among these microorganisms? And One, as I stressed before, is the widespread inappropriate use of broad-spectrum antibiotics. If there's anything you can take away from me today, as I said before, AMR is a natural phenomenon, and it's only amplified by our use, by drug pressure. And unfortunately for us, there's a lot of use of drugs and used not the way they are supposed to be used. We use them inappropriately. And of course, some of these are broad spectrum. You just give blunderbuss treatment. You go to hospital, you're given drugs per symptom. And sometimes hospital is actually not the biggest problem, but community where you go and people take these drugs by themselves, self-medication. In Uganda, you can find a pharmacy maybe in every 2 or 3 kilometers. There are so many, there are drug shops, there are pharmacies. So drugs, antibiotics are available and we misuse them. And there's also the use in animals and the use in plants. Using this in feeds, growth promoters, using drugs to prevent disease. So this is very important for us to think about, and use of these drugs also in fisheries. So everywhere there, people are doing business, people who have feedlots, they give drugs to these animals so that they don't get infected. They don't get infection. So excessive use of antimicrobial preparations in soaps and cleaning solutions in non-healthcare facilities. You find, we're using these drugs, antimicrobial agents, using them in other non-healthcare related issues. And of course, there is also the problem of the number of people who are HIV positive, and this population is growing. And some of these require prolonged use of antibiotics. Before the test and treat, we had a lot of use of Septrin among HIV patients, and they were on this for quite a long time. And so literally you could never use Septrin, which is a very good drug and cheap. You could never use it to treat somebody who is HIV positive. And probably not just them, but if they have a bug that is drug resistant to Septrin, they pass it on to somebody in their family, that person also can't be treated with Septrin. And there's international travel. We can, take these bags with us very, very quickly. You have this new India metallo-beta-lactamase, which, has moved from many, New Delhi, not in New India, New Delhi metallo-beta-lactamase, which is an ESBL genotype that has moved from India to across the world. You know of COVID, which moved through many parts of the world. So these resistant organisms are able to be carried, across borders. There is no boundary now. And of course, poverty and disease are quite very related. Poverty and disease, this is where you find somebody who is, they say you have typhoid and you're going to take these drugs for 2 weeks. And you say, I can't afford the dose for 2 weeks. Can I get a dose for 3 days? Can I buy for 2 days? So poverty is very, very related to drug resistance. And also, because of poverty, there is malnutrition. We get exposed to disease, and therefore we'll need drugs more common, more so than those who are not poor. And there are other misusers of drugs. These are things that we all know. Drugs, organisms, they are those that have innate resistance. They generally are resistant, whether they have been exposed or not, they will be resistant to drugs. And all members of a species are resistant even before the introduction of antibiotics. And there are those who could be due to lack of a target. So because they don't have the target, they don't have a cell wall, for example, you won't use these penicillins on gram-negative organisms, and the limited transfer from one strain to the other, as opposed to acquired resistance, which is easily transferable even between unrelated species. We know we have use of the viruses that transfer resistance from one bacteria to another. They exist. These basically are genes that move and are carried either as jumping genes or carried by viruses or carried by pili between bacteria. And these are able to carry resistance in strains that were susceptible before, but now are very resistant. And this is one of the mechanisms that we fear quite a lot, because organisms really acquire resistance quite often. These are some of the mechanisms of how these bacteria do resist antibiotics. Okay, so bacteria are not sitting, you're pumping them with all these antibacterial compounds. They also put up a resistance, they put up a fight. That's why I told you drug pressure is really tough and gives these organisms opportunity to build their own resistance. And they can do this through enzymatic destruction. They come and destroy, like those that destroy the beta-lactam ring, or we call them the beta-lactamases or the penicillinases. They just destroy. Other bacteria, actually, they change the target, like in penicillin resistance, they come and change the penicillin binding site, or they can block the intake. So you don't have a lot of organisms coming in, or others have efflux pumps where they pump out the drugs like tetracycline. They will just pump them out, increase the elimination. They also they could change their metabolic pathways so that your target doesn't really, the drug doesn't reach the target. Oh, what's happening? So, as we said, when you give sufficient time and drug use, and microbial resistance emerges. That's the key cutting word. If you continue to use a certain drug, push it onto these organisms, naturally they will switch on their resistance mechanisms. And when they have switched on these mechanisms, they now spread. And sometimes when they spread, you won't be able to control them. And this developed progressively, evolving from low levels through intermediate to high levels. So you find some organisms have low level resistance, others have high level resistance. So it is progressive and keeps moving. The more pressure you put, the more switches they put on. And organisms that are resistant to one drug are likely to become resistant to others. As I said, depends on how, whether it's innate or acquired resistance. So if it's an acquired resistance, you can actually acquire more plasmids, you can acquire more phages and become more resistant to more classes of resistance. And once resistance appears, this is another message that we need to carry with us, that once resistance appears, it declines very slowly, if at all, okay? Once resistance appears, it declines very, 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 very slowly. So that means if you find a drug that an organism is resistant to, it is almost not going to be usable in the near future. Probably in our lifetime, we may never see chloroquine coming back to be used, even Fancida. These were easy drugs, less side effects, cheap, but we may never see them coming back to treat malaria. And we are seeing now artemisinin resistance beginning to come up. You've seen in HIV, lots of resistance comes up to nevirapine. So these drugs may never be able to be used. Some people have said if you reduce the drug pressure, maybe you can use the drugs, but it's a very long process for you to reintroduce that drug. And so, the next point is also very important. As you and I take drugs, we need to be careful that me using a drug may actually affect others who are going to use that drug. Because if I misuse it and the organisms that are causing disease in my body become resistant, that resistance can easily be passed on. And when it is passed on, it's gone. You will have, for you, it will be primary resistance and not secondary resistance. So how do we then deal with this resistance problem. One is withhold antibiotics in certain situations. If you don't need a drug, don't take it. That's the basic message that we have. We need to use our diagnostic stewardship where we really improve our diagnostics so that we are able to treat infections that we have diagnosed, not suspected to diagnose. If somebody has a flu, which is commonly viral, we shouldn't give them antibiotics. So that's how we save these drugs. And then if we are going to use, we need to use drugs not with broad spectrum, but with narrow spectrum.